Okay, in this video we're going to look at common factoring techniques in combined cases. And what I mean by combined cases is we need to deal with constant coefficients as well as variable parts or unknown parts. I'm going to do this in steps. You can always do this in one big step, but I'm going to do this in smaller steps just to make clear. So the first step we're going to do is I'm going to deal with the constant parts. So I'm going to look at the constant coefficients. So that's 3, 9, and negative 12. I know a common factor of all those is 3, so I'm going to be left with 3 times what gives me 3, and the answer is 1, so I have x cubed. 3 times what gives me 9, and that's 3, x squared. 3 times what gives me negative 12, and that's minus 4x. Okay, so now I am going to check again, see if there's a constant coefficient that can be factored out, because maybe I didn't pick the best one to do. But in this case I did. So now I'm going to look at the variable part, and that's the x's. So I see I have x cubed, x squared, and x. So I can only take out x to the power of 1. So x to the power of 1 times what gives me x cubed, and that's x squared, plus 3. X to the power of 1 times what gives me x squared, and that's x, minus 4. And if I factor out the x, it becomes 1. And I'm done. Now let's look at this next one. So the constant parts are negative 7, 14, and 21, so I can factor out a negative 7. And notice in both these cases I factor out and I will be left with a constant coefficient of 1 in at least one of the cases, but that's not always going to be the case. So I have a squared bc cubed plus, a minus and a plus gives me minus 2a cubed b squared c squared minus 3a cubed b cubed c squared. Okay, so I've factored out that constant part, and so now I'm going to look. So let's see if we can do a couple things together. So I have an a in this term, I have an a in this term, and an a in this term, so I definitely can factor out an a. I see a squared, a cubed, so I can factor out a squared. I have a b in this one, I have a b in this one, and I have a b in this one, so I can definitely factor out a b, and I have b to the power 1, b squared, b cubed. So the smallest one there is going to be b to the 1. And then I have a c in all three of these, so I'm going to factor out c cubed, squared, squared, so I can factor out a squared. So I'm going to get negative 7, and then a squared times what gives me a squared, and that's 1. b times what gives me b, and that's 1. c squared times what gives me c cubed, and that's c, minus 2. a squared times what gives me a cubed, and that's a. b times what gives me b squared, and that's b. c squared times what gives me c squared, and that's 1. Minus 3. a squared times what gives me a cubed, and that's a. b times what gives me b cubed, and that's b squared. c squared times what gives me c squared, and that's 1. And I'm done. Now I want to do one more example here because I think it's hard. Every time I finish these, I always think of that other case. But let's make sure we just are familiar with this one. Let's make up one real quick, and I have, I don't know, 2 ab plus 4a squared b squared d. Okay, so if I was to factor this, what I look and I see is the constant coefficient 2. And I see I have an a in both of them, so I factor in an a, and I have a b in both of them, so I factor in a b. And then this one has a d, but the first term doesn't, so I can't factor that out. So I say 2 times what is 2, and the answer is 1. A times what gives me a, and the answer is 1. B times what gives me b, and the answer is 1, so I'm left with 1. I have to write a 1 here because there's nothing else there. 2 times what gives me 4, and the answer is 2. A times what gives me a squared, and the answer is a. B times what gives me b squared, the answer is b. And I'm still left with d. Okay? So the two little points here is that if you factor out the entire thing, you're left with 1. And sometimes you might not be able to factor out from one of the terms one of the unknowns. All right, I hope this video helped.